Asani, can you hear me?
Yes, sir.
How was session yesterday? Unit 1.
It was great, sir. It was great. We did 2011 paper yesterday.
The 2011.
Yes, sir.
Okay. Alright. Oh, and also I'm going to send you Unit 1 solutions. I have Unit 1. You got all the Unit 2 solutions, right?
Yes, sir.
Yeah, I'm going to send you all the Unit. I've worked all the Unit 1 solutions from 2008 to 2017. So I'll get those to you.
Yes,
Just
sir.
remind me later. Right? There are some nice, lovely young ladies that are going to join us, but I think they're running a little bit late, so they'll join later on. All right, so in the meantime, I wanted some persons from our school to be here, but John Mark is going to join soon. All right, so I guess we can one-on-one go through these. All right, so the first one right here, what's the first thing you do when you see this? E to the minus ln x. What comes to your mind when you say that, Asani? Asani, you there?
Yes, sir. I'm here. I was having a little bit problem with the mic, the mute mic.
Okay. All right. So I'm saying for the first one, what comes to your mind when you see that?
Uh,
Sorry. What comes to your mind when you see e to the minus ln x?
what comes to mind?
Yeah, what
Exponent
comes
is
to
it
your mind?
like
Repeat?
differentiation?
No, as in it say, how can you write this expression? E to the minus ln x. How can you write that expression?
Oh, sir. That would be x or minus x.
Let's see. You said
That'd
minus
be e. You can rewrite it as e to the
e to the
ln of
minus
x.
e
E
to
to
the
the
minus ln x. You can always bring the minus one up in the power. And so you
yes,
get
sir. That's what I wanted to say.
e to the ln x
Of
to
x
the
to the
minus
minus 1.
1. But then e cancel ln,
Yes, sir.
and say
So
get x to the minus 1. But what is x to the minus 1?
1 over x.
1 over x. So that's the answer.
What paper is this, sir?
This is 2010.
2010. All right.
Good day, Jermaine.
Sir, good
Yeah, good to
afternoon.
see you. Good to see you, Jermaine. Good to hear from you.
Uh,
All right, as we gear up towards
no. For
exam,
Okado.
all is well?
Yes, sir.
All right, very good, very good. So what you going to give me for the exam, Jermaine?
Well, sir, only my best.
Only a best. All
Yes, sir.
right, all right. That's what I want to hear. I'm really happy you're here. And so that's it. E to the minus ln x can be written as 1 over x. All right, so I just wanted to write this down. Very important to note this, that e to the ln of any number a is equal to
A.
a. That's one thing to remember. Another thing to remember is if you say a times ln e, that's
Is
equal to
A.
a.
Because
And
the
another
ln of
thing,
E is 1.
exactly. And another thing to remember is if you say ln e to the a, that is,
A ln E.
that's also a. All right, so they like to write these a lot. they like to rotate them. All right, but all of them is the same thing. All right, so that takes care of question 1. Question 2, it says that we have x plus 5 divided by x times x squared plus 6x plus 17. So how are you going to express this now as partial fraction?
You can break the quadratic fraction into 2 linear
Can
fractions.
you, so break the quadratic, what are the 2 factors when you break this quadratic?
Let us see. Let me just what is this again? X squared plus
6x plus 17. So let me ask you a question. How do you know when you can break a quadratic into linear factors? How do you know when you can factorize it?
When you can factorize it.
Yeah, how do you know when you can break it into linear factors?
When there are three terms in the quadratic equation, sir, so you can split the middle term into 2.
All right, but sometimes you can split the middle term, but you still cannot factorize it because
They
it's
can use the
irreducible. So sometimes you have what's called an irreducible quadratic, and that cannot be split, right? And so because that cannot be split, because the irreducible quadratic cannot be split.
yeah, this can split for real.
Yes, so because this cannot split. Yes, Jermaine, go ahead, you can speak.
Oh, sir, I was saying because the number at the end doesn't have any factors.
17 is basically like a prime
17
number.
doesn't have any factors.
Exactly, very
One on
good,
itself.
very good to highlight that. Very good. All right, so we know that 17, we cannot split 17, right? The only way you can split 17 is 17 times 1 or 1 times 17. All right, but either way, if you were to expand x minus 1 times x minus 17, you'd notice that when you work it out, you're not going to get back this.
Yes, sir.
All right. All right. And so therefore, this has to be broken up as, so this is how we do that.
So the answer D, sir. D as in dog.
D.
D as in dog.
So for this question, that's question 2, you would have to break it as, here it is. So this is 2010. Yes, we're doing 2010. Why my solution different here? All right. So this part, what we'd have to do is break it as a over x plus b over x, bx plus c over x squared plus 6x plus 17.
Linear over quadratic.
And so it's not d, it is c.
Oh, C, sir. Yeah, yes, sir.
Yeah.
C. That's
It's
what I
C.
wanted to say.
Yeah. That's what you have to break it as c. Easy question. All right. Question 3. It says, given that a, b, c, and k are constants, then what is the integral of 3 over x squared times x minus 1 dx? How you'd go about tackling that?
Sure.
So first things first, I would just pull out the constant. So I would say 3 times the integral of 1 over
You sure you want to do that?
x squared times x minus 1 dx.
You sure you'd want to do that?
Why not, sir?
Why you don't want to do that? The first thing I would think about doing is
Or
notice
partial
that,
fraction.
exactly, partial fraction. And so this is what you should, the first thing should come to your mind right there is partial fraction. And so you go 3 over x squared times
3 over x
times x minus 1. I can always write that as
a over, no,
x
ax plus
squared
b.
A
So
over x. A over x plus b over x squared, because this is repeated linear, plus c over x minus 1. That's how we'd write this one, right?
sir, but wouldn't this be wouldn't it be bx plus c over x squared since it's linear over quadratic?
Repeat. Why is it bx plus c? Remember what we spoke about for repeated linear. When it is repeated linear, like you have x minus 1 all square, it would be a over x minus 1 plus b over x minus 1 all square. Remember?
Okay, okay.
And so because it's x squared, it is a over x plus b over x squared plus c over x minus 1.
Okay,
All
okay.
right? Yeah, exactly.
Wait, sir. Where shall we get the x from?
All right, I'm saying we have x squared right here, and this x squared can be written as x times x, right? X squared can be written as x times x. And so therefore it is what is known as repeated linear. The formula that you need to remember for repeated linear is a over the linear factor by itself plus another constant b over the linear factor squared. All right? And so it's going to be a over x plus b over x squared. And then you're going to put c over this x minus 1. All right?
Yes, sir.
Yes. Good evening, Ashley. How are you doing?
Good evening, sir. I'm okay.
How was your IA last week? You didn't get back to me.
Oh, well, module 3 was very hard, but she make us do a redo, and I think I did well in it.
Okay, and the redo was better.
Yes, sir.
Okay, all right, that's good to hear. So what we're doing now today is we started 2010 MCQ. We're just going through 2010 MCQ for today.
Okay,
Because
sir.
all we're doing for the rest of the week is MCQ papers. Oh, she can't speak. Unmute. Yes, Denny, go ahead. You can speak now. She hearing me? All right. Don't know. Why is it not unmuting? All right, as we were saying, so to integrate this now, we'd have to integrate this right here. And so therefore, the integral of all of this is going to be equal to the integral of all of this. But when you're integrating this side now, how would you integrate a over x?
It is the ln x.
That's a ln x. How do you integrate b over x squared?
B ln x squared.
B ln x squared. How do you integrate b over x squared? Remember, b over x squared can be written as b times x to the minus 2. This can be written that way. You see the trick now? So what would be b over x squared?
Minus 2.
How do you integrate b x to the minus 2?
It would be b times x to the minus 1 divided by negative 1.
All
That'll
right.
be minus b
minus
times
b
x to the minus 1.
over x. That's minus b over x.
Yes,
And
sir.
how do you integrate c over x to the minus? How do you integrate c over x minus 1?
So wouldn't that be c times the ln of x minus 1?
Can you repeat? I didn't hear you.
Would that be c times the ln of x minus 1?
That would be plus c times ln.
The ln of x minus 1.
Very good, very good. And then plus some other constant, k.
K. Yes, sir.
That's it, easy, soft. And so that's
Oh,
all we ask people.
I should be aware of like the middle, like in the middle term, like b over x squared. I should be aware of that.
Yes,
When I'm
right here. This
integrating
was
it.
the trick part. So a lot of
Yes,
persons
sir.
gonna think everything is ln, but that was the trick in the middle right here.
Yes, sir.
All right. And so let's look at which answer looks like that. And that looks like
Dog.
D. All right. So they put plus B right here because really and truly B is a constant. And so we can call it plus B or minus B. It doesn't matter. Okay. All right. Next question. So we're clear with that one, right?
Yes, sir. Continue.
All right. Question 4. Question 4 now asks us what is the integral of cosine 5x times cosine 3x. Now to integrate cosine 5x times cosine 3x, we have to remember back some trig identities.
Yes, sir. I think it's something like the sine of A minus the sine of B. Is something like that, or
Something
it's
like that, yes.
or the
So
cosine
this
of A
is
plus
what
the
he's
cosine
trying
of
to
B.
say. The cosine of P plus the cosine of
Cosine
Q.
of
That's equal to 2 times the cosine of P plus Q divided by 2. P plus Q divided by 2. That's equal to twice the cos of half the sum times the cosine of half the difference, which would be P minus Q over 2. So you have to remember this formula. And if you choose not to remember it, then you just have to go back to the formula sheet. All right? So that's the formula you have to remember. Have to remember that.
So 2
that's what we have
cosine
to
P
remember.
plus Q.
So cos P plus cos Q is twice the cos of half the sum times the cosine of half the difference. All right? And in this question, look at the question now. All the options gives you 8x and 2x. So clearly they're telling you P is 8x and Q is 2x. So what you do is you say, okay, so the cosine of 8x plus the cosine of 2x, cosine of 8x plus the cosine of 2x is going to be equal to 2 times the cosine of 8x plus 2x divided by 2. But 8 plus 2 is what?
10.
10, and 10 divided by 2 is what?
5.
All right, so you get 2 times the cosine of 5x. And then now what is the cosine of P minus Q over 2? That's 8x
Alright, so it's 6.
minus
Alright,
2.
so all that is 3x. 3x.
3x. So this is cosine of 3x. All right. And so therefore, if you want the integral of this cosine 5x times cosine 3x, you can divide both sides by 2. So you get this side to be a half over here. And then 2 divided by 2, this part becomes 1. And so we get a half of cosine 8x plus cosine 2x is cosine 5x cosine 3x. And so when you integrate both sides now, so the integral of cosine 5x cosine 3x is equal to the integral of a half cosine 8x plus cosine 2x. And then you look which one that is. Here it is, D. Why then he cannot speak? Unmute.
So that the mute button them now work good, sir.
Yeah, I'm wondering. I'm trying to unmute. Yes, everyone should be able to unmute now.
Sir, why is number 5 a module 3 question?
Number 5 is a module 3.
Yes, sir.
Yeah.
It's a whole time paper, this man.
Yes, this is 2010. That's the reason.
The syllabus never did change in time there.
The syllabus changed in 2013.
Okay. Okay.
Right. So what you'd notice is that these multiple choice questions are more likely to be seen now in the module 3. All right.
Yes, sir.
So that's question 4. Question 5 now, it gives you the differential equation. And it says find the general solution of the differential equation. Right. The first thing that you have to do to find the solution for this differential equation, the first thing you have to do is to write the auxiliary equation. What would be the auxiliary equation for this?
M squared minus 3m plus 2
All
equals
right.
0.
Very good. So you're solving m squared, that's auxiliary equation, minus 3m plus 2 equals 0. And what's the value for m when you solve this?
M squared
minus 1 x minus 2.
All right, so minus 1 minus.
minus 1 and minus and
Very good. So m is equal to 1 or m is equal to 2. If m is equal to 1 or m is equal to 2, then what we find is that the general solution is going to be y is equal to
okay.
a
The
times
roots are real and distinct. So that'll be in the form ax plus b times e to the m1x.
Very good, yeah. m1x, which is 1 times x plus b times e to the 2x. All right?
Oh, yeah. E to the a times e to the x plus b times e to the 2x.
Yes. So you have to remember when the roots are real and distinct, it takes this form. All right? And so that's it. Easy question.
So m that equal to 1 and m that equal to 2.
So that's B.
A e
That's B.
to the x. So a e to the
A e to the 2x plus b e to the x.
does it really matter which one you take to be your first root, sir?
No, it does not matter. That's the thing. It doesn't matter. So I may write it as a e to the x plus b e to the 2x, but it's the same thing. Because when you solve, when they give you the particular integral or whatever, in order for you to be able to can solve for the constants, you're going to get the same thing. So say you call this P and you call this Q. At the end of the day, when you solve it, it will work out. The constants will work out to be the same value. All right.
Right, sir. Why I feel like I lose some marks on a module test because of the order in which I wrote my differential equation.
No,
and
you
my
don't.
general solution.
You didn't lose any mark for that issue. Don't worry about it.
Okay.
All right. Look at question 6 now. It says x is equal to log with base a m, and they want you to find log m of a to the 5th over m. So what do you think? What comes to your mind when you see something like that?
Rules of logarithm.
Rules of logarithm. Sorry. See if I can center it. All right, so rules of logarithm. So which rule is coming to your mind when you see this one?
What is going where would I go again? God.
All
right, so it's called the change of base rule. That's the one.
Yes, sir. That I can understand the logs and I for unit 1. That's the one there alone. The logarithms I can understand. Change of base.
So this is how change of base rule. First of all, they want you to find this log to base m of a to the 5th over m. That's what they want you to find. All right. Now look at this. First thing, when you have log A over B, you can rewrite it as the log of A minus the log of B.
Yes, sir.
Oh, this is A to the 5th minus the log of So that's how you write it. The log of A over B is the log of A minus the log of B. Good.
So,
Now
but you
look
know,
at
so this
this
should have
now.
work out to be 1 though. Log of m to the m.
Yes, this part is 1. So now we can use rules of logarithm to bring down this power to get 5 times the log base m of A minus log to base m of m.
Yes, sir.
Now look what they told us. They told us that x is equal to log to base A of m. That's what they told us x is equal to. All right? That's what x is equal to. So now look at this. We need to write this in terms of x. So look how we're going to do that. We're going to rewrite this as 5 times. We're going to change the base. Now this is how you change base of a log. The log of a base of some number n, I can change it to a new base. The log of some new base, let's call it c of n, but then I'm going to divide it by the log of that new base of the old base. That's a change of base rule. All right? And so therefore, this right here, I can write this as the log of the new base, which I want to write it in terms of a, and the number is a, divided by the log of the new base a of m. So I change the
Yes, sir.
base. Can you hear me?
Yes, sir. I'm asking if that's how you do it.
Yes, that's how you do it. So you change the base right there. All right? But now, we know that log of base a of a is 1.
1.
That part is 1. And then log base a of m, they told us, is x. That's x. Minus 1. So the answer is
1 over x minus 1.
5 over x
5 over x minus 1.
minus 1. That's what we're looking for.
So, all right. So 5 times the log.
So here it is again. All right.
5 times the log of m to the base a. If I want to change this base, it's going to be 5 times the log of a to the base a divided by log to the base a of m. Okay.
Exactly.
Something like this we get for the module 1 test in a sense. The hard logarithm equation that we'll get. Now that we could finish.
So this one would be B. All right. Now finally they ask an easy question. How to differentiate sine inverse. Right. This would be a walk in the park.
Answer cat.
So let's just write it down formally. So we have y is equal to sine inverse of 2x. How are we going to differentiate this?
Sorry, it's going to be 1 over the square root of 1 minus 2x of the square of 2x. And
1
then I
over the
differentiate
square
2x.
root of 1 minus
2x in bracket and then a square root.
So 2x all square is just 4x squared. Then what?
So that's what I'm saying. You bracket 2x and then a square root.
Yeah,
All
when
right,
you bracket 2x and you square it, that's 4x all square.
You multiply by the derivative of 2x, which is 2.
Which is 2. All right, so that's the answer. 2 over 1 minus 4x all squared. So that's 2 over 1 minus 4x all squared. Easy. And that's question 7. Let's go to question 8 now. Question 8. So it tells us that sec square is equal to 1 plus tan square, and then it asks us to integrate tan square divided by 4. So the first thing we're going to have to do is to make tan square the subject from this.
Which is a secant square x minus 1.
All right, very good.
By 4 dx.
Very good. So we have just seen, if we're to rewrite that, we're getting that tan square x is equal to secant square minus 1. And so therefore, if we can integrate tan square, we're pretty much just going to integrate secant square. Pardon me for leaving off the dx. Never leave off a dx, but because it's MCQ, we don't have to pressure the dx. All right? When we integrate secant square, what are we getting?
Secant square, we're getting tan x.
Tan x. So we're getting tan x. And when we integrate 1, what are we getting?
So I mean a quarter.
X.
Integrating 1. When you're integrating 1.
X.
Oh, x. X.
You get x. All right? And then we're integrating from
0 to pi.
From 0 to pi. Integrating from 0 to pi. From 0 to pi. And so therefore, we just
Mr. Ferguson.
Yeah.
Remember the function said the integral of tan square x over 4.
Yeah, over 4. So what I'm going to do at the end is just whatever we get multiplied by a quarter.
Oh, I thought you forgot.
No, I didn't forget. I was going to say that last. Yeah, so you can always just put the quarter on the outside, and the answer that you get, you multiply it by a quarter. And so when we plug in pi first, remember that the tan of pi is 0. And so we put in pi, we get minus pi. And then we put in 0, we get 0. So we get minus pi minus 0. And so then we're going to times the final answer by a quarter. So let's put times a quarter on the outside.
The minus pi over 4, the answer then.
Yeah, so the answer is minus pi over 4. Minus pi over 4. Easy, right? Soft. Right. So now this question is asking us, what is the integral of 1 over the square root of 16 minus x squared dx?
It'll be 1 over the square root of 16 minus x squared dx. So first it'll factor root 16 from out of the square root times 2.
So you want to factor out 16 out of the square root sign?
Yeah,
yes, sir. So be like
why would you want to factor out 16?
Can't factor out.
All right, square root it, so they get 4.
All right, so I'm going to write down a rule that you can remember. It's an easy rule. The integral of a over the square root, this is a rule to remember. The integral of a over a squared minus x squared. This is equal to sine inverse of x over a. All right, so you don't need to factorize it. So now the question is asking for the integral of 1 over the square root of 16. 16 can be written as 4 squared minus x squared.
That'll be 4 over 4 over the square root of 4 squared minus x squared.
All right, nice. So very good. You can put a 4 right here, but then put back a 4 on the outside, a quarter. All right. And so what we get that integral is equal to is a quarter of sine inverse
of x over 4.
Very good. A quarter of sine inverse of x over 4. Easy stuff. Soft. That's B. All right, nice. That wasn't bad at all. All right. Now this, how are we going to integrate this one now?
3. Lose 3 squared.
Sir, it is 1/3 times the tan inverse of 3x plus c.
Oh, get that. Oh, get 3x. But that's not here. Oh, get
Rewrite
the
the 9x
3x.
squared as 3x all square, right? And then the
That's
difference.
what I wanted here. I want to hear that you write it as this 3x all square. All right. Once I hear that you write it as 3x all square, I'm fine. All right. But then how you get the 1/3 now? Tell me how you get the 1/3.
One,
I
one,
want to,
one, 1 minute there, sir. You can go
Yeah.
back to the
sir,
previous
you're
screen,
gonna
please.
multiply by
Wait,
the
wait,
base
wait.
plus of c.
Let me hear it. Go ahead. Go back to what?
You can go back to the previous, yeah.
This one?
Yeah,
Okay.
1 second. All right, sir. Thanks.
All right. Yes, let me hear how you get the 1/3 now. What was done to get the 1/3? All right, so what was done to get the 1/3? What I was hoping to hear was you put 1/3 and put a 3 in the numerator.
Yes, sir.
And so it becomes, that's now equal to 1/3 tan inverse of
Tan
3x.
inverse of 3x plus
Yeah.
a constant k.
Plus a constant. It don't matter what you call a constant. But today I'm going to call that constant R. Just to stop using C and K. They use too much C and K, right?
True.
1/3 tan inverse of
So
3x.
tennis boy.
Easy. All right. Now this is question 11. All right. So it says dy by dx is 2x times y. What is the value of d2y by dx squared at 1, 2? So what's the first thing we have to do?
So this
This what?
Find the second derivative.
Yeah, so we have to find the second derivative. Hi, Shane. Good day. How are you?
Hello, sir. I'm okay.
Oh, how was the module exam? You didn't get back to me.
Oh, right, sir. Sir, it was good. We're just waiting on the results, though.
Okay. All right. I know you did very well.
Hoping that is the case.
Okay. Were some of the questions repeated?
Yes, sir. From
Okay.
what you did?
Yes, from what? From what you had sent me.
Oh, yes, sir. Some of them were repeated.
Okay, that's good. All right. So as she said, first thing we have to do is find the second derivative. So to find the second derivative, we'll find y double prime, and that's going to be equal to, we differentiate this, which is we keep the first, differentiate the second, plus keep the second, and then differentiate the first, which is plus 2y. So we have to use implicit differentiation to find the second derivative. And it wants the second derivative at the point 1, 2. So we're going to have to plug in x as 1 and y as 2. So the second derivative at this point is 2 times x being 1. Now remember, dy by dx was 2xy. And so if you put in 1, 2 right here, you get 2 times 1 times 2, which is 4. So dy by dx at that point is 4, plus 2 times y, which is 2 times 2. And so therefore, that's what we do to get the second derivative at this point. And the second derivative at this point is 8 plus 12, 8 plus 4, which is 12. All right? That's how we get the second derivative at the point 1, 2. Second derivative at the point 1, 2. There it is, 12. All right. How do we integrate sine square? How do you integrate sine square? This is an easy question. All right, so to integrate sine square, we have to remember that first and foremost, this is the identity I want us to get familiar with. Cos 2x.
Cos 2x, yes, sir.
Cos 2x
is
is
equal
equal
to
to
1 minus
what?
2 sine square x.
1 minus 2 sine square x. Very good. And so if you want to integrate sine square x, you have to make sine square the subject from this. And so I can bring over, and so 2 sine square x,
And then you divide by
2 sine square x is equal to 1 minus cosine 2x. And so you can divide both of it now by 2. Divide by 2. Divide by 2.
Sir,
Yeah.
wouldn't it be cosine 2x minus 1?
Bring over. No, 1 minus cosine 2x. So what I did was bring the 2 sine
I get what you're saying. I get
here.
what you're saying.
Okay.
I get it now.
So that's what we do. So from right here, what we end up getting is that sine square x is really equal to 1 over 2 minus cosine 2x over 2. That's what we get. And so now, when we're integrating sine square, we're just going to integrate a half. So we're integrating a half minus cosine 2x over 2. And when we integrate cosine 2x over 2, what we get?
The response is totally
So now we're going to get a half x.
Half x.
We get a half what?
Sine
minus a quarter sine 2x.
Wait, Asani, let her speak. Let me hear it. What you said? What you said, Ashley?
Sir, never mind, sir.
No, go ahead. That's why I said go ahead. Go again. Go again.
Oh, thanks. Sir.
I was just saying is sine.
Yeah, when you integrate cos, you get sine, yes? But you said something after that. I wanted to hear what you said after that.
Sine 2x.
Times 2x?
Cosine 2x.
Oh, sine. Oh, I thought you said times 2x. Times 2x. Yeah?
And then it 2.
that belatedly, and due to
all right, and 2 times 2 is what?
high electricity bill, we are seeing some response. In addition to summoning,
you always, of course, put a constant of integration.
The opposite regulation, you are. However, the opposition.
That's right here.
You are does have a role to play in the matter. Their delayed response will not provide for consumers.
Right.
In addition to questioning the data, he is again calling for legislative changes in the price mechanism.
Asani, I'm going to mute you for a second. Just see if you can turn down that in the background. Yeah. All right, so now we have a function f is defined by f of x is equal to 2e to the 3x minus 1 for all real values of x, and they ask us for the inverse. So in order to find the inverse, what we learned from CSEC days is to interchange x and y. So they tell us that this is f of x. So to find the inverse, well, what we do, we say, well, f of x, this f stands for f of x, f is equal to, they told us f is 2e to the 3x minus 1. So f is 2e to the 3x minus 1. And so to find inverse, we interchange x and y. So you write x is now equal to 2e 3y. Some people say y. I'm not going to say y. I'm going to say f inverse minus 1. And so we add 1s to both sides, and so we get x plus 1, and then we divide by the 2. So x plus 1 divided by 2 is equal to e to the 3f inverse. And so now, to get the f inverse what we want, we take the natural log of both sides.
Sir, what question is this?
This is question 13.
What was number 12 answer again?
Number 12 was D, dog.
Dog.
Yeah.
Okay.
All right. And so we take the natural log of both sides, and so we get the natural log of x plus 1 over 2 is equal to the natural log of e to the 3f inverse, but the natural log of e is 1, so it's just 3f inverse. And so we're going to divide both sides by 1 over 3 to get f inverse is equal to 1 over 3 times the ln of x plus 1 over 2. That's the answer. Easy question. That's a C-set question to find inverse. So that's what they do. All right. Easy question. That's what they were asking us. To find f inverse. 1 over 3 ln x plus 1 over 2. Oh, and this is a nice question. Look at D and look at C. Both of these are the same thing, but the domain defined are different. Now it has to be C because x cannot be a negative number. So x can be real, but x cannot be a negative number. If x is a negative number, we cannot find the log of a negative number. And so therefore x has to be greater than -1. So that's key when you're selecting this option. All right. That's question 13. If at any point you want me to go back through anything, stop me. Question 14, they're asking us, yeah.
Could you, after the number 14, can you go back number 13 again?
All right, let's just go back through it now. Go back through the whole thing or the domain part?
The whole thing.
All right, so let's go back to number 13. So generally, this is a function, f of x, all right, f, right? F meaning y. So y is equal to 2e to the 3x minus 1. And in C-sec, what you're taught is to find the inverse now, you interchange x with y, and then solve back for y. So that's what we did right here. We interchange x with y. This is your y now. So interchange x with y, and now we solve back for y. In this case, our y is f inverse. All right? And so that's all you're doing. You're solving back for y now. So to solve back for y, you add 1 to both sides, and then you divide by 2 to make 3e, e to the 3f inverse, the subject. But then to get the f inverse out of the power, you have to take the log of both sides. So after we take the log of both sides, what we get right here now, the log of e, or ln e, is 1. So we just get 3 to the f inverse is equal to ln x plus 1 over 2. We can then multiply both sides by 1 over 3. And then the 3 is going to cancel that 3. And so we get f inverse now is going to be 1 over 3 ln x plus 1 over 2. And then when you look at your answer, you're going to see 2 of them is the same, but the domain defined is different. But then you have to remember x cannot be negative. And so x have to be greater than -1. Because if x is negative, then you're going to take ln of a negative number. And the ln of a negative number does not exist. Ln of a negative number does not exist. All right? So that's what we do to get C. Question 14. Question 14 tells us that if log 10 of 2 is equal to x, Then what is log to base 10 of 0.128 in terms of x? The first thing I'd like to do is write 0.128 as a fraction. What is 0.128 as a fraction?
So 12.8 divided by 10, sir.
What is this as a fraction?
No. 12.8 divided by 100.
Yes, so write that as 128 over 1,000. Then write it as 128 over 1,000. But then 128 is 2 to the what? 2 to the what? 2 to the 6 is 64.
Yeah.
2 to the 7. 2 to the 7. Very good. Over 1,000. That's 0.128. And so now I can take this now, and so the log to base 10 of 0.128, log of base 10, it's just going to be equal to log to base 10 of 2 to the 7th over 1,000. Now this now can be broken up. You have log of 2 to the 7th over 1,000. That can be broken up as log A, which is log of 2 to the 7th, minus the log to base 10 of, now look how I'm going to write 1,000. 1,000 is 10 cubed.
Yes, sir.
1,000 is 10 cubed. Now, log 2 to the 7th is the same as 7 log 2. And log 2 is x. And so this is just 7x. That's clear? Because right here, I could have bring down the power. Instead of writing the 7 right there, by rules of log, I can bring down the power right here to get 7 log 2. And they told us log 2 is x. Then minus. Now what is, well, this 3, I can bring down the 3. And so this is 3 log 10 of 10. But log 10 of 10 is 1. So it's minus 3 times 1, which is 3. So the answer is 7x minus 3. 7x minus 3. Easy question. 7x minus 3.
We have assigned 40 persons to do the so definitely this week there will be.
Okay. All right. Question 15. It is asking us now for the number of bacteria present. It tells us that the number of bacteria present in a culture is modeled by y is equal to y naught e to the kt, where y is the population and t is hours. Find the rate of growth. So the rate of growth is dy by dt, and they call the rate of growth c. So we need to just find dy by dt when t is equal to 5. All we're going to do is differentiate this. So how do we differentiate exponential? We differentiate differentiate the power. And we're going to differentiate this power, and so we just get k, so we get k y naught e to the kt, and then we'll substitute t as 5, and so we get k y naught e to the 5 times k. That is c. That's clear? That's clear?
Go back that question again. That solution.
Okay. I'm saying no, so let me write it down. We have that y is equal to y naught e to the kt, and we're finding dy by dx. What's dy by dx? What's dy by dx? dy by dt rather.
You're gonna have to apply the product rule, sir, or
You don't need to apply product rule. Y naught is a constant.
Oh, okay.
So you just differentiate this. And
Also, it'll be
differentiate
K, Y naught, E to the KT.
K Y naught e to the kt. Very good. And then they ask us, what is this? They call it differential c, by the way. Then they ask us for the derivative when t is 5. So we're just going to substitute t being equal to 5 right here. So substitute t being 5 right there. And
Oh,
that's
okay,
it.
okay.
And
Okay.
that's it. So it's ky naught e to the k times 5, or 5k.
Yes, sir.
And that's C. Easy question. All right. Now look at this question now. So now we're out of module 1 and we're into module 2. So we're into sequence, series, and approximation. Now this question says, for 2n to be less than 1, what is this sum? They're asking for the sum to infinity. Now the sum to infinity is a over 1 minus r. And so what we need to do is list out these terms then. So the sum from 1 to n, from 1 to infinity rather, of 2r, 2n to the r, we can substitute all the values. Did they say from 1 or from 0? They said from 0. So they said from 0, so this should be 0. From 0 to infinity is when r is 0, anything to the 0 is 1, plus when r is 1, we get 2n, plus when r is 2, we get 2n squared. And so if you keep on continuing and continuing,
It's diverging.
not necessarily, it said it's converging because it told us
Oh,
that 2n is less than 1, so it's converging. And so all we need to do is find the common ratio. The common ratio is T2 divided by T1, which is the second term, 2n, divided by the first term. So the common ratio is 2n. And so therefore, the sum from 0 to infinity is the sum to infinity. Sum to infinity is the first term in the series, 1, divided by 1 minus the common ratio. And the common ratio is 2n. So the sum to infinity is 1 over 1 minus 2n. That's clear?
Yes, sir.
That's the sum to infinity. 1 over 1 minus 2n. A over 1 minus r, yes. In this case, our r is 2n. A over 1 minus r, that's sum to infinity. All right.
sounds like geometric progression.
Yes, it's a GP. All I did was write the GP in sigma notation. Now this question now, before I do this question, I want to just write down this. Just bear this in mind. Always bear this in mind. The
So what's
sum,
number 16 answer again?
number 16 is 1 over 1 minus 2n.
And the answer is
D.
boy. Okay.
All right. Question 17 now. Always bear this in mind. The sum from r equal 1 to n, I can write that as the sum from 1 to k plus the sum from k plus 1 to n. So always bear this in mind. The sum from 1 to n, I can break it down. For example, if I'm adding from 1 to 3, 1 plus 2 plus 3, right? I can add the sum of the first two terms and then add the third term. Or let's say I'm adding 1 plus 2 plus 3 plus 4 plus 5. I can add the sum from 1 to 2 first and then add the next 3 terms. All right? So always bear this in mind that the sum from 1 to n can be broken down as the sum from 1 to k plus the sum from k plus 1 to n. Generally, the sum from 1 to n, they're going to call that Sn. And then the sum of the sum, so you can call Sn the sum from 1 to n. That's always going to be Sn. And so Sm is always going to be the sum from 1 to m. That's Sm. And then they're going to tell you that m is less than n. All right, so look at this now. The sum from 1 to k is the sum from 1 to n is Sn. Then they want the sum from m plus 1 to n. What is going to be the answer?
It's the sum n it is S sub n minus, it will be n plus S sub n plus 1.
It's going to be Sn minus Sn minus. That's Sn minus. That sound right so far. Sn minus which one?
Minus.
So let's write it down. So look how we're going to do it now. So they told us that the sum from 1 to n is Sn. We already write it, and the sum from 1 to m is Sm. So already write them down. And then now they ask us to evaluate the sum from m plus 1 to n. M plus 1 to n. Now look at this now. The sum from 1 to m plus 1 plus the sum from m, all right, the sum from 1 to m plus m plus 1 to n. So not m plus 1 here, so the sum from 1 to m plus the sum from m plus 1 to n, what is that equal to? What is this going to be equal to? So we're summing from 1 to m plus from m plus 1 to n. That's the sum from 1 to n. Agreed?
Yes, sir.
And now the sum from 1 to n is Sn. And the sum from 1 to m is Sm. So Sm plus this thing, the sum from m plus 1 to n, is equal to Sn. So if we subtract Sm from both sides, we get that the sum from m plus 1 to n, the sum from m plus 1 to n is equal to Sn minus Sm. Easy question. That's all they're asking us. So it's Sn minus Sm. So it is Sn minus Sm. Easy, soft. All right. Now this question asks us, for what values of x is the series convergent? The series is convergent when the common ratio is
Less than
between,
1.
all right, very good. It's convergent when the common ratio is between 1 and -1.
Yes, sir.
So first of all, we have to list out that thing there. It gives us that S is equal to the summation of x to the r from r being 0 to n. That's Sn. So if we were to list it out, when r is 0, you get 1 plus x squared, and it continues. So what we can clearly see is that the common ratio, let's call the common ratio r, is equal to t2 divided by t1, which is x. So the common ratio is x, and so it's going to be convergent when x is between 1 and -1. That's when this is going to be convergent. And x is between 1 and -1. And look for
Number
that
18 is
C. Easy question. All right. Now this question, this is just something to remember now. What is the binomial coefficient equivalent to? So I want you to remember this now. Always remember this. N choose R is equal to, so this is something new to remember. N choose R is equal to N choose N minus R. And so therefore, when you write it in vector notation or matrix notation, NR is equal to N minus R. So that's something to remember. All right. So just remember this. N choose R is equal to N choose N minus R. All right. And we can prove it. We can prove it if you want. N choose R, remember it's N factorial over R factorial times N minus R factorial. That's N choose R. All right. And so you can do the same and replace R with N minus R now, and you're going to get the same thing. All right. So you can just remember it. N choose R is equal to N choose N minus R. N choose R is equal to N choose N minus R. That's B. Now this question asks for the coefficient of a squared b to the fifth. Find the coefficient of a squared b to the fifth in the expansion a plus b to the seventh. So we want to find the coefficient. So to find the coefficient, you don't need to expand all of it. You just need to look
Wait, sir, you can go over number 19 again, please.
Number 19?
Yes,
oh,
sir.
Number 19, all we were saying is there's a simple formula to remember. Always remember this. N choose R is equal to N choose N minus R. All right. So when you're doing combinations, this was the first thing that we wrote down. N choose R is always equal to N choose N minus R. And so in vector notation or column or matrix notation, it's NR is equal to N minus R. And you can always check it. I can tell you for a fact that 5 choose 2 is equal to 5 choose 3. You can check it. You can always use numbers and test these questions.
Okay.
All right, just give n a value and test it. All right, and that's number 90. So if you're in an exam, and let's say they barely tweak this. Let's say they tweak the question this year and put n choose 7. All right.
That'll be
They
n
put
choose
n7.
n minus 7.
Yes, n minus 7. All right. And let's say they give values for n now. Let's say they said 22. What would be that equivalent to?
20
2.
and 20 minus 2.
All right. Yes, that's what it's equivalent to, which is 20 choose 18. Very good. All right. So that's all that's all they can do to twist a question like that. Now this question is asked for the coefficient of a squared b to the fifth. If you have a plus b to the fifth, all right. If you're to look at the third term, so the first term you choose 0, the second term you choose 1, the third term you choose 2. So let's look at the third term. The third term is what we want. The third term is a squared b to the fifth. That's the third term. And we're choosing, so we're 5. So this is going to be 5. It's always corresponding with the second one. And we're choosing 7. So the coefficient of a squared b to the fifth is 7 choose 5. Now let's look at this now. We just got a question that told us what n choose r is equivalent to. And so 7 choose 5.
7 choose 7 minus 5.
7 minus 5, which is 2. So 7 choose 5 is also equivalent to 7 choose 2. So I bet you that they're not going to put 7, 5. They're going to put 7, 2. I can bet you any money.
Nah, you lose, sir.
Oh, I lose my money. I'm so sorry. Yeah, I lose my money. My bad. I just thought from the follow-up question that they would put something like that, but they didn't. Okay, nothing is wrong with losing a bet every now and again. Okay, now this question, it gives us a sequence and it is defined as un plus 1 is equal to 1 minus 1 over un. All right, and so now they're asking for the 20th term. So all you're gonna have to do is observe the pattern. These sequence always follow a pattern. So un plus 1 is equal to 1 minus 1 over 1 plus un, and they told us that u1, where u1 is 1. And so if you're to find u2, you're going to see that u2 is going to be 1 minus a half, 1 minus a half, which is a half. That's u2, right? Because if you put 1 right here, you get 1 over 1 plus 1, which is 1 over 2.
Yes, sir.
1 minus 1 over 2, which is a half. You're going to see that u3 is then going to be 1 over 1 plus u2, but a half plus 1 is 1.5. 1 divided by 1.5 is 2 over 3. 1 minus 2 over 3 is 1 over 3.
Yes,
so
sir.
u3 is 1 over 3.
Oh, so the general term are going to be un equals to 1 over n.
Exactly. So u4 is 1 over 4. And so therefore, we can conclude, u20, what they asked for,
u20 is equal to 1 over 20.
Very good. u20 is 1 over 20. That's where the pattern is going to, which is A. Easy. Soft.
That's what they said, that's A?
Yeah, that's A. Okay, question 22. Very easy question. This is a CSEC question. CSEC ADMA. They're asking for the sum to infinity of a geometric series. Sum to infinity.
Again, it's like 1 minus A to the R over 1 minus R.
He said A over 1 minus R.
Yes, A over 1 minus.
Yeah. A over 1 minus R. So it's 16 divided by 1 minus R. R is 12 over 16. 12 over 16 is 3/4. So 16 over 1 minus 3/4 is 16 over 1/4, which is 64. That's an easy question.
I'm going to go over back progression.
Yeah, so you have to revise progression notes. I can resend you the notes by email.
No, sir, no need to do that. I'll use my textbook.
Okay. All right. So that's the sum to infinity. A over 1 minus R. Easy formula to remember. Now 23, they're asking us to find the sum to infinity, but now they put it in sigma notation, but they're asking for the same thing. So all you have to do is get it out of sigma notation in this form that we're used to. So it's the same thing. The sum from n equal 2 to infinity is sum to infinity again. So let's get it out of sigma notation. It's always easy when we get it out of sigma notation. So it is the sum from n equal 2 to infinity of 2 to the minus n. So the sum from 2 to infinity of 2 to the minus n.
Same as 2 over n.
Same as 2 over n?
No.
N over 2.
N over 2?
No, sir, no, sir, no, sir, no, sir. No.
Yeah, no. And a 2 over n.
A 2 over n.
A 2 over n, sir.
Yeah.
Oh, I was right.
Yeah, I was just checking how confident.
Oh, and then I can put the 2 behind the Big E, sir.
So it's 2 over n. You don't need to put it behind of it because we're going to substitute in n as 2 now. All right. So substitute n as 2 first. We get 2 over 2 is 1 plus n is 3. We get plus 2 over 3. N is 4. We get 2 over 4. And it continues. So now we can find the common ratio. The common ratio R is going to be 2/3 divided
by 1, which is 2/3.
Wait, just to check and see that in order to know if it's actually a GP, you need to see if 2 over 4 divided by 2/3 gives you the same value. So check what is 2/4, what's 2 over 4 divided by 2 over 3.
So 2 over 4 divided by
3.
a 3/4. I get still in, sir.
3/4. All right. So now what you have to notice is that this is not giving you a GP.
Geometric.
All right, so it's not a
It
geometric
can be a
progression.
geometric progression then.
No, it cannot be a geometric. So
But
we
can
do
it be
know.
arithmetic?
No, it's not an arithmetic progression. So we're gonna have to find another means to solve the question. All right, and look how we're gonna solve the question. Look how we're gonna solve it. All right, so I'm gonna write this as, write it back as 2 over 2.
Yeah, you can do that.
So now look how you're gonna write the numerator. The numerator,
Yeah,
we're just
2
summing 2 n times,
over
right?
n plus 1.
We're summing 2 n times. So keep adding 2 n times. So in the numerator is 2 times n. Agreed?
2 times n? Are
Yes,
we trying to
we're
find a
summing
general
2.
term, sir?
Yeah, we're fine. All right, just think of it as this way. Think of it as, instead of seeing s infinity, think of it as s. Well, I don't want to say n. Think of it as s from 2 to k. Think of it as summing from 2 to k. Think of this as k first. We're going to find the sum to infinity, but think of this as k first. If it's a sum from 2 to k, then we'd be adding 2 how many times? K times. So it would be 2k. Then what would be in the denominator now? Now in the denominator we'll add 2, then we'll add 1 more
So that'd
point.
be n plus 1.
N plus 1 in the denominator. N plus 1, which should be k plus 1.
Yes, sir.
K plus 1. All right. Now look how you do this. To know what the sum to infinity is, right, we're going to have to find the limit to see where this is going towards.
The limit.
The limit, yeah. So what would be the limit as k goes to infinity of this? So the limit
over infinity plus 1.
The limit.
Sir, this look like why this look like a diverge?
No, it not diverge. When you see something like this, divide through by the highest power of k.
So it'll be 2.
2 over 1 plus 1 over k.
1 plus, yes, sir.
So as k goes to infinity, it is 2.
2.
So what we're saying is
converging then.
it is actually converge, right? And so it is converging to 2. That's the sum.
Didn't see that one coming.
All right, so that's what you'd have to do. Easy question. I'm just checking. Wait, give me a second. Because if you add, this is 1 plus 2/3. 1 plus 2/3 is 1 and 2 over 3. 1 and 2 over 3 plus a half. That should be more than 2. That should be more than 2. And then you add 2 over 5. Look what I'm saying. This is what I'm saying. You have 2 over 2 plus 2 over 3 plus 2 over 4 plus 2 over 5 plus 2 over 6. Keep adding this. you're going to get something that's bigger than 2. Clearly. Are you getting what I'm saying?
Yes, sir.
Yes, that's what I'm saying. So the limit is 2. So it's converging to 2, but the sum is not necessarily 2. The sum is not 2. So the limit is 2. That proves that it is convergent. So we're going to find the sum now. So we actually need the sum of this. So we
The
need the
sum
sum of this. From k being from 2 to
infinity.
infinity. So we need the sum. So we need to sum it from 2 to infinity. This is where there are many different ways to do it. So this shows that it's convergent. So that's what that would do. That shows you that it's convergent. And so how I'm going to write this is, look at it, don't freak out, it's easy. I'm going to break this up. So remember, we're summing this. Integral and sum is the same thing, so don't worry about it. We're summing from 2 to infinity. I wouldn't want you to be integrating though. You can integrate it and you're going to get the answer, which is the sum. We're going to use summation. So I can break up this again now as 2k over k plus 1. All right, I can write this as add 2 right here and subtract back 2. So I add 2 and subtract back 2 in the numerator. And so what I get is I can factor out 2 now from this part, and I get 2k plus 2 minus 2. I end up get 2 into k plus 1 minus 2 over 2 over k plus 1 over k plus 1. Now summation and integration are the same thing. And so this k plus 1 cancels this k plus 1, right?
Yes,
And
sir.
now, if you're integrating now, so what you're finding is the sum of 2 minus 2 over k plus 1, which is 2 minus 2 over k plus 1. Now you should be able to integrate this from 2 to infinity and evaluate its sum.
So
Or
the integrating test here,
yes, this is this is not integral test, but this is finding the sum. All right. So you can use the integral test to find the sum. But why the summation? Why the summation? Wait, let me look at something. Because I don't recall where I did this pre-hand. I did this pre-hand before today. I don't recall using integration. I broke it down as a summation. But I don't know why that method not coming to me right now. It's a different people. But the sum should be bigger than 2. As I said, 2 over 2 is 1. 1 plus 2 over 3 is 1.67. That's 2 point something already. That's 2 point something. They want what is the sum. Then A cannot be 4. It's not being 4. So I guess A has to be 2. I'm going to find a solution with the summation part. Oh, you can integrate it from right here, but I don't want you to use integration. I need to remember, how did I break it as a summation? I don't want you to use integration and find it. I want it to evaluate its sum. All right, so I'm going to find it. I have the solution written down. All right, this one now, When you see this question, what comes to your mind? The coefficient of x squared in the series expansion, 1 minus 3x to the minus 1/3. What comes to your mind?
Binomial expansion.
Binomial expansion, but which one?
Or
Of
the extension one.
the extension
No.
formula? What's the extension?
1 minus nx plus n minus 1 over 2
Yes,
factorial.
that one.
1 plus nx plus n times n minus 1
Very good.
times x squared over 2 factorial.
Very good. I love that. We remember it. So 1 plus x to the n, as we said, that is 1 plus
nx
plus
time plus
n
n times n minus 1 over 2 factorial.
over 2 factorial. Or you can just put 2.
Yes,
plus,
sir.
okay, and it asks for the x squared term, so we can stop right there. Now notice that our x in this case is minus 3x.
Minus a quarter.
And the n is minus, that's a quarter?
Oh, sorry, sir. Wrong question. I was
minus 1/3.
reading the wrong question.
This is minus 1/3. Yeah, this is minus
So
1/3.
n is minus 1/3 and our x is negative 3x.
Yes. So we have 1 minus 3x to the negative 1/3. Now we don't need to look at these two parts. They just want the coefficient of x squared. So the substitute n as minus 1/3 times minus 1/3 minus 1/3 is
Minus 4.
minus 4 over 3 divided by 2 times x squared. So what is minus 1 over 3
There's a
times
4 over 9.
That's 4 over 9 divided by 2, which is
4 over 18.
4 over 9 divided by 2. You sure?
4 over 9 times a half, sir.
Yeah, 4 over 9 times a half.
So 4 over 18, that's sir.
2 over 9.
2 over 9.
2 over
Yeah,
9.
same thing. 4 over 18, yeah. Yeah, 4 is the same thing.
Got 2
Okay.
x squared.
Okay, and remember, right here, this shouldn't be x squared. This should be minus 3x all squared.
Yes, sir. So we nearly get tricked there.
Almost got tricked. All right, but minus 3 squared is what? 9.
9x
Squared.
So
9x squared
we're getting 2 over 9
times 3
times 9 times x squared.
times 9, yeah.
Which is
So
which
the
give
9
it
It's simply 2x squared.
yeah, so the coefficient of x squared is 2. Easy. All right, now this question is they're asking for the coefficient of x cubed in 6 minus ax to the 9th power. So what comes to your mind when you see this question?
Binomial theorem.
Binomial theorem, the other one, the other expansion. So they want, this is 6 minus ax to the 9th power. So 6 minus ax to the 9th power. That's what they want. That's going to be equal to 6 minus ax to the 9th power. So that's going to be equal to
6.
They want the x cubed term. So which one are we looking for? The x cubed term.
The fourth term?
The fourth term. So the fourth term is we're choosing 3 from 9 of 6 to the 6 times minus ax to the third, right? And they told us that the coefficient of this x cubed term is
84, negative 84 as well.
negative
So 9
84.
choose 3.
So
9
this is negative 84 x cubed. So it's equal to negative 84 x cubed.
84
So we need to
times
make
6.
a the subject from this. And so what I would say you can do is, instead of, remember that minus a times x all cube is really minus a cube times x cube. All right? And so we can divide through, or this should be 6 to the 6. We can divide through by 9 choose 3, 6 choose 6 to get a minus a cube x cube is going to be equal to minus 84 x cube divided by
9 choose 3.
9 choose 3 times 6 to the 6. Now this negative,
Really?
yes. So we divide both sides by 9 choose 3, 6 to the 6. Now the negative here, cancel the negative here, and the x cube, cancel the x cube. And so we get that now a cube is equal to 84 over 9 choose 3, 6 to the 6. And so a is going to be equal to the cube root of all of that there. Here's the cube
A
root.
what try to find, sir?
Yes, we're trying to find a. So a is the cube root of 84 over 9 choose 3 times 6 to the 6. So how to put this in a calculator can be confusing. So I'd say work the denominator first. So put in a calculator 9 choose 3 times 6 raised to the 6. So put that in a calculator first. You get 1 million and something. Then you're going to say 84 divided by that answer that you get. So 84 divided by that answer, I'm getting 5.14 times 10 to the minus 5. Then you're going to cube root that answer that you get. And when I cube root it, I'm getting 1 over 36. I get 1 over 36. So that's the easy way to put it in a calculator, because it's difficult to put all of this in a calculator unless you're putting in a lot of brackets. So you put 84 divided by bracket, 9 choose 3 bracket, 6 to the 6 bracket, then you cube root it. That's a lot to put in a calculator.
No, I prefer do it, you know.
Repeat?
No, sir, I was just saying that I prefer do it, putting all of the brackets in the calculator.
Oh, okay, okay, okay. All right. Now, this question is saying the true length of a piece of pipe is 50 centimeters and it is measured to be 51 centimeters. What is the relative error? The relative error is...
36 meters all going on.
You get what?
Wait, you say you get 36?
1 over 36. When you cube root it, you get 1 over 36.
Oh, John,
Yeah, check it again.
check it over.
Yeah, so work this part in the calculator first. 9 choose 3. What you get for 9 choose 3?
84.
84. No. So if I get 84, 84 divided by 84 is 1. And
1.
so what you have is 1 over 6 to the 6. So put in a calculator 1 divided by 6 to the 6. Tell me what you get. 1 divided by 6 to the 6.
I got 2.143 times 10 to the minus.
All right, now cube root that answer. Cube root the answer.
Cube root, all of them get while ago?
Yes, cube root all of that. So let's put in a calculator cube root answer.
I got 0.0277.
Press the fraction button now.
What is this fraction button?
Press the fraction button. The fraction button is something that says A, B over C.
Just press it like that, sir?
Yes, just press the fraction button after the answer appear.
I'm not going for my calculator.
Is a Casio you have?
No, sir.
Oh, I don't know how you're gonna get that then, but so you get 0. You should get 0.0277777.
Yes, sir. That's what I got.
That's 1 over 36.
Okay.
All right. Now this question is asking about relative error. So relative error, we'd have done something like this in physics or something way back from grade 9. So relative error is the true value minus the measured value divided by the true value. So it's true value minus the measured value divided by the true value. That's relative error. All right?
So 50 minus 51
So
and
50,
divided by 50.
so you say 50 minus 51, then you divide it by 50. So that's
That's negative 1 over
1
50.
over 50, but you take the modulus because length has to be positive. So you take the modulus, and so that is 1 over 50, but then 1 over 50 as a percentage is
2%.
So that's the relative error. 2% error, relative error.
So 50 minus 51 over 50.
Yes, so 50 minus 51 over 50, that's relative error. All right? That's relative error, that's D. Now, question 27 is asking us to use Newton-Raphson method to find an approximation xn, and we're finding an approximation of the root. All right, I'm not going to call it xn plus 1 or xn. That's a lot of subscript to be writing out. So I'm going to call it alpha. I'm going to call it alpha. And so they tell us that x cubed is equal to
X.
Oh, x to the fifth rather. X to the fifth is equal to
X cubed.
minus or plus.
I think it's plus 25.
Plus 25. Plus 25. Now the first thing, the function have to be equal to 0 before I can use Newton-Raphson. So I can bring everything over to one side. I like when the highest power of x is positive. Minus x cubed.
Minus x cubed plus 25.
Minus 25.
Minus 25.
Or minus 25.
That's equal to 0. That's equal to 0. All right. So that's what we have now. And so therefore, we can call this now f of x.
Of x and find the second derivative.
That's f of x. So now we can find the derivative, f prime of x.
Sorry.
I'll find the derivative. It is
5x to the 4th.
Yeah.
Minus 3x squared.
All right. That's the derivative. And so now the root alpha, or xn plus 1, is equal to, I'm not gonna write xn. That's too much subscript. I'm gonna call it a different root. I'm gonna call it A. Yeah, or B. Let's call it B.
Yes, sir. Because I'm gonna make the A look like alpha.
Yeah, let's call it B. So B minus f of B. F of B is gonna be 5 to the 5th minus B cubed minus.
Sir, so I'll make you change the x to B.
Oh, it's f of B. It's gonna be B minus f of B over f prime of B.
Yeah, but why are you changing?
So if we want to call it x, then it would have to be x minus f of x over f prime of x, right?
Yes, sir, that's true.
Yeah. So no, that's why we're using B. The B does represent xn. Let's just tell it B represent xn because it's a lot of subscript.
I understand.
Writing. And so this would be now 5 b to the 4 minus 3b squared. So we can write this now as one fraction. So bring it as one fraction. So it's going to be b times all of this. So multiply b times all of this to become b times 5b to the 4 is 5b to the 5th.
5b to the 5th.
Then minus, that's 3b
cubed.
Now, when you expand in the minus now, you're going to get minus b to the 5th plus
b cubed plus 25.
Plus 25 divided by 5b
to the 4 minus 3b squared.
Exactly, 5b to the 4 minus 3b squared. All right. And so 5b to the 4 minus b to the 5b to the 5th minus b to the 5th is 4b to the 5th. So it's 4b to the fifth minus, well, minus 3b squared plus b squared.
Negative 2b cubed.
Why am I saying square? I should say cube. Yes, negative 2b cubed. Negative 2b cubed plus 25. Over the denominator.
Mm-hmm.
All right, so we know what the denominator is. And so we're looking for 4b, 4xn to the fifth minus 2xn cubed plus 25. That is d. Because it's in b. That's it. That's an approximation of the root. That's an easy question, right?
Mm-hmm. Yeah, yes, sir.
Yeah. Now they said that the sum of the first n term in a series is 1 minus a quarter n. Find the second term. So this is how we're
Extension of
going
a binomial expansion.
No, we don't need to do that. We're just using the formula that they give us. So they tell us Sn is equal to 1 minus a quarter. A quarter what? A quarter to the n. That's Sn, right? And we know that in general, Sn does mean we're adding up all the terms of the sequence, which is A1 plus A2
plus A3 and continue.
all the way up to An. And so S1 is going to give me the sum of the first term, which is just the first term. So I get 1 minus a quarter to the 1. It's a quarter. And so the first term is 3/4.
3/4.
So that's A1. Now S2 is going to give me the sum of the first two terms, which is A1 plus A2. And A1 plus A2, that's going to be equal to plug in 2. I'm getting 1 minus a quarter square, which is 1 over 16. 1 minus 1 over 16 is 15
over
over 16. So now, if I know S1 is 3/4, which is the first term, I can find the second term. And so 3/4 plus A2 is equal to 15 over 16. So I need to transpose for A2. So I just bring it over. And so that looks to be, I can rewrite 3/4 as 12 over 16. And so it's going to be 3 over 16. So A2 is 3 over 16. 3 over 16. 3 over 16, right?
Yes, sir.
We sure? Times this by, this can be written as 12 over 16.
12 over 16. So 3 over 16, that's sir. Is 3 over 16.
Just making sure, because sometimes we can make simple addition errors. When you have those simple stuff, don't be afraid to put it in your calculator. You might feel embarrassed, but prevention is better.
Nobody's embarrassed about that, sir.
Right. Yes, sometimes I know some persons feel embarrassed to write 5 over 4 times maybe a half.
So you ever type in 1 plus 5 in your calculator in our exam?
No, that's overdoing. But I've been in the staff room and I've seen teachers afraid to type 22 over 5 or 22 over something times 1. I've seen them looking around, afraid to type it in the calculator. So it's just something natural with us as humans, where we're supposed to know these things, but you know, as humans, we make simple mistakes sometimes. So now this question is telling us a music artist sells 48,000 CDs in the first year, right? And the sales are halved each subsequent year. And so in the second year, it's 24,000. The third year, it is 12,000. All right. And so clearly it's a geometric progression, right? Let's write it down. So this is what happened. in the first year himself 48,000. So I'm just going to use 48. 48 represents thousands. Then the next year himself 24,000 because each other year it's half. Then the next year himself 12,000. Then the other year 6,000. Continue. So clearly it's following a geometric progression where the common ratio R is 24,000 divided by 48,000. 24 over 48, which is a half. So the common ratio is a half. All right. So let's see what they ask for now. They're asking now the value of sales for a particular year. So the value of sales in a particular year. So we can call that L. In a particular year, it is, remember, it's A for geometric progression, any particular term
A
is
plus
R to the n minus
A
1.
to the R, A R to the N minus 1.
So it's pretty much 48 times the common ratio of half to the n minus 1. The only difference is that because it is in price, and they told us the price for one CD, whatever you get, you're going to have to multiply it by 25, because $25 is the cost for a CD. So we look for, yes, so the 25 is there, so it's 48 times a half to the n minus 1 B. That's it. All right.
What is number 32?
Number 32 is easy. Don't worry about that. When we get there, we get there.
Okay.
Number 30. It says two quantities, y and z, are measured. Results rounded correct to two significant figures are 9.8 and 9.3. The lower and upper bound respectively. Now before we do this question to find lower and upper bound, I want to show you something. All right. So 9.8 to two significant figures, that could be anywhere between the region of 9.75 to
9.79.
9.84.
Oh, okay.
That's
Okay,
how you round off to 9.8. So it can be anywhere between this region, right? It can be anywhere between that region. 9.3 now can be anywhere between what region? 9.25.
9.25 and 9.34.
9.34, very good. So to find the upper bound, right, we can actually subtract 9, if you work out 9.84 minus 9.25, that is going to give you the upper bound, the maximum bound. All right.
That's
So
going to give us like 0.09.
So 9.84 minus 9.25, that is what?
9.25, sir?
Yeah. So to get upper,
84.5.
That's 0.59. That's what you get?
84 minus.
Yes, sir.
So the
0.5.
upper bound is approximately
0.59. 0.59.
All right, so the upper bound is approximately 0.6. Now to get the lower bound, it's gonna be, we're gonna say 9.75 minus 9.34. Tell me what you get.
0.4.
0 point what?
0.41.
0.4. So the bound is between 0.4 and
0.6.
So you see how this question can be tricky? Can be a little bit tricky. 0.4 and 0.6. The only reason why you're not going to see the 0.41 and the 0.59 is because they're working with two significant
figures.
All right, so this is a physics, this is like a 10th grade physics question or a grade 9 physics question. Right. So on to module 3 now. It says two events, A and B, are such that the probability of A is 0.5, the probability of B is 0.16. Find the probability of A intersect B. What's the formula to find the probability of A intersect B?
The probability of A plus the probability of B minus the probability of A intersect B.
So the probability of A intersect B is what?
It is the
PA plus PB
probability.
minus the P of union.
Yes, very good. So it's a probability of A plus the probability of B minus
the probability of A union B.
Very good, yeah. And so they gave us the probability of all of these. And so all you have to do is just
stick them
plug
in the
in
formula.
value. Yep. So 0.5 plus 0.16 minus 0.48. You don't even need calculator for that. That's just 0.18.
The only topic we love in a probability.
That simple formula, right?
Yes, sir.
Easy.
Simple thing that.
All right, let's look at this question now. It says M is that matrix, and they want the first row of the cofactor matrix. So the first row of the cofactor matrix, well, first you have to make a cross like this.
Yes, sir. That'll be plus,
so
and in bracket
4, 1, 5,
6 minus in the bracket now -2.
So the first term would be what? When you find it, that's 19, all right? And then now we need the second row. That means we need to cross this one. So what's the determinant of -2, 1, and 0, 6?
-12 minus
-12.
Yeah,
negative. But then remember that the cofactor is negative, right?
Yes, sir. So it's +12.
So it's +12. So it is A. So you don't even need to go any further. So you see how this question is easy?
That's true. The whole skip them throw me off, you know.
The star, no, the star. You're like, why is that star? They just want the first row. That is why.
Okay.
All right. Now this question is very easy. Determinant of 8 squared. You don't even need to work it out. This is a rule of modulus anyway. The modulus of 8 squared, and you find its modulus, it's always going to be equal to the modulus of h all squared.
Yeah.
That's a rule of modulus from
Unit
1. And so the determinant of a matrix square is just the determinant of the matrix, and then you square it. If you don't believe it, you can always make up an example and see. For example, let's say you have the matrix 2, 4, 1, 2. The determinant, so let's say you have the matrix 2, 4, 1, 2. Square that matrix 2, 4, 1, 2. When you square that matrix, what you're getting is,
all right,
2
times 4. 2 times 2 plus 4 times 1
is 8. And then what's here? 2 times 4 plus 4 times 2. That's what?
Yes,
16.
Sir.
This is 16, right?
Yes, sir.
Then what goes here? 2 plus 2
1
is
times
4.
2. 1 times 2 plus 2 times 1.
And then what goes here?
1 times 4 plus 2 times 2.
Which is 8.
That's not telling you how you work it out, you know, sir.
Repeat?
I'm just telling you how you go about working it out, you know.
Yeah, I know. So look at this now. Call this a h. What would be the determinant of h? The determinant of h in this case would be?
64 minus 64, which is 0.
Wait.
What?
Oh, I use a bad example. Oh my God.
That would have given 0.
Yeah, this is a singular matrix, so it's always going to work out to be the same. This is a bad example. But take it from me. This is it. The modulus of h squared is equal to the modulus of h all squared. All right?
Yes,
so take it as gospel. It's just a rule of modulus. For example, 5 squared, the modulus of 5 squared is the same as the modulus of 5 all squared. That's it.
Yes, sir.
That is C. Oh, why is this rotated this way? What is going on here? Oh, let's see what's going on. All right. Question 34. Now, first and foremost, when you're solving for the intersection of lines, right? I just want to show you something. There are only two possibilities. If you have three lines, this is a line, this is another line, this is another line, right? There's a possibility none of the lines intersect. That's one case. Another case is I can have a line right here, another line right here, then the other line is out here. And so a case I can have where one intersect, right? And then you have another case where all three of them meet. But notice that it would be at one particular point, right? And so what I'm trying to say is from the tell you about 3 point of intersection and 2, these two automatically out. If it's lines, it only can meet at no point or 1 point. All
Wait, so you
right.
can go over that again?
I'm saying these are all the possibilities with lines. The 3 lines can either never meet because they're all parallel, or 2 lines can meet and the other one never meet these 2 lines, right? And so therefore this would have no solution because it cannot solve all 3 of them together. And then there's a possibility.
So the ones where all of them are parallel, they'll be unique?
The ones where all 3 of them are parallel, this has no solution. They will
No
never
solution as
meet.
well.
Yeah. This would have no solution as well. And when all 3 of them meet at 1 point, that has one solution.
One solution, right?
All right. So that's it. So lines can only meet at either 1 point or no point. All right. So that's it.
Yeah.
So first and foremost, 2 and 3 out. Now look how we're going to check if they intersect. Now look at this first equation. If you multiply this equation by 2, you get the second equation, right?
Box.
Right?
Yes, sir.
If
Yes,
you
sir.
multiply this first equation by 3, you should get negative 15, right?
Yes, sir.
But this one I give you negative 25. So that don't make no sense. Because
No.
of the same x, the same y, and the same z, and so it has no solution. The system is known to be inconsistent. There's no way I can add the same 3 terms and get different values. So the system is inconsistent. And so therefore, no solution exists. So that was the trick to that question. All right?
Yes, sir.
So that's how you do that one. Now, this question now, the roots of the equation x squared plus 1 is 0. Just tell me the answer. This one is too easy.
Negative I and I.
Negative I and I. That's too easy.
Sir, how we get that?
So you carry over the minus 1, so x squared is negative 1. Then you square root both sides, and so you get x is plus or minus the square root of negative 1, but the square root of negative 1 is I.
I.
So you get plus or minus I. Now this question now, you have P and we have Q, and they want the first row. They're always asking about the first row. So it is this row times this column. That will give us 2 times 2 is 4. Then minus 15 is negative 11. Then we have minus 3, which is negative 14. So the first one is between C and D. Then we need to go first row and second column. It's the second matrix. So we get 2 plus 0 minus 2, which is
0.
So C is the answer. So those questions you don't need to spend a lot of time working out. That's C. All right. Question 37. So we need to find the determinant of the matrix M. So given that this have a 0, we can use the first column to find the determinant. So using the first column, we get the cofactor of 3 would be 3 times 4, 12, minus 2 times 5, which is 12, minus 10, which is 22. Then 22 times 3 is 66. So getting 66. Then this is going to be a plus minus plus minus. So then now we need to find the cofactor of this 2, which would be negative 4 minus 15, which is negative 19. Wait, negative 4 minus negative 4 minus 15 is negative 19, right?
Repeat,
Yes,
Yes,
sir.
sir. Yes, sir.
yeah, that's
Yes,
negative
sir.
19. And then we times it by 2.
Minus 30.
124.
What's that? Let's just write it down. I don't
Yes,
know
sir.
why it's just not working out in my head right at this moment. Usually what we find is that the later it is in the night, that's why they try to let math exams be at 9 a.m. Because usually by 1 p.m. the brain becomes a little more tired in the day. So we have 320. We have 320. We have minus 135. Minus 135. And then the last column is 5, negative 2, 4. 5, negative 2, 4. So the determinant of this matrix, let's call it M.
All
The
right, so that'll
determinant
be 3 times 3, negative 2, 5, and 4.
3, negative 2, 5, and 4.
4.
Yeah.
Negative 1.
We want to use
Plus
negative
1,
1.
plus
It'll be
1,
plus
plus 1.
1. Would have to be plus 1 because the negative and the negative make it positive. So it's plus
Yes.
1. Why would you use the first row when you have a 0? But okay, let's use the first row.
I always use it.
Yeah, I understand. We always use the first row. So that's what we're used to.
0, 4.
2,
I would
negative
use
2, 0, and 4.
plus 5 times. I
Plus
would
5
definitely
times.
use the
Plus 2, 3, 0, 5.
2,
2,
3,
3, 0, 5.
5. I don't know why you guys wouldn't use the first column because it have a 0 that done already. So this part works out to be 12 minus 10.
12 plus 10, sir.
Yeah, so that's times 3 is 22, times 3 is 66.
66.
66. Then we have 4 times 2 is 8. 8 minus 0, so we have
Plus 8. But that's
then we have
74.
10. Then we have 10 times 5 is 50. So that's 58 plus 124 is
124.
Yeah.
Sir, but
121.
we wouldn't do this in the exam.
Repeat?
We wouldn't do this in the exam.
Why?
We would just type it, put it in the calculator.
Yeah, exactly. Because MCQ, you don't need to be wasting time.
Right.
Yeah. Time is too precious.
Yeah.
Right?
Well,
Now, they ask us the roots of a quadratic equation is ax squared plus bx plus c. All right?
so what was number 36?
36. That was c.
Oh, okay.
All right. So first and foremost, we can always write a quadratic equation in the form x squared minus the sum of the roots plus the product of the roots. All right?
Yes, sir.
Clearly, the sum of the roots would be 3 minus 3 plus I. So it's x squared minus the sum times the product. The product of these two roots is going to be 4 plus 3i, clearly. How do I know it's plus 3i? Because I minus I times I is going to be negative I squared. And the negative I squared is going to turn it to be positive. So looking for something with plus 3i. So it is
Sir,
x.
another way to do this, couldn't we say something like since the roots are 1 plus 2i and 2 minus I, wouldn't it be like z minus 1 plus 2i multiplied by z minus 2 minus I?
Yeah, you can work it from there as well.
And
Yeah,
then
that is
when you
it.
get the equation and compare it to with one out of the 4 options.
Yeah, you can do it like that too. That's how you can do it as well. But the easier way is just to look at the roots and remember that a quadratic is written in the form x squared minus the sum of the roots plus the product of the roots. So it's b.
Yeah. B.
There's no need to be able to say z minus bracket 1 plus 2i. Then you can say let z be x plus y. By the time you're doing all of that to get the answer, that's too much work. That's way too much work. This question now we're rationalizing.
The denominator.
Rationalizing the denominator. So multiplying by 3 minus 2i. So let's do that. So we have 2 minus I. We have 2 minus I divided by, what was that question?
3 plus
2i.
2i.
We have 3 plus 2i. And we're multiplying by 3
minus 2.
Minus 2i.
3 minus 2i.
All right. So multiplying, so 2 times 3 is 6. 2 times negative 2i is minus 4i. Minus I times 3 is minus 3i. And then minus I times minus 2i is minus 2i squared, which is
2 plus
2i squared, and plus 2i squared is minus 2.
Oh, yeah, sorry.
Yeah. And then we have the difference of 2 squared in the denominator. So it's going to be a squared plus b squared. So it's 3 squared plus 2 squared. That's what it's going to work out to be. So it's 6 minus 2 is 4 minus 7i over 13. Easy question. Soft. Easy like Sunday morning. Oh, it's 7. Which one was it? 4 minus 7i.
4 minus 7i.
Yeah, that's D. They put C as a distractor. If you're not really focused, they're just going to say, oh, that's C.
True.
All right, so now they're asking for the expression of I times 1 plus I squared minus 1 minus I squared. Now to do this, what you're going to have to do is you have I times bracket I plus 1 all squared. I plus 1 all squared is just going to be I squared plus 2I plus 1 minus I minus 1 all squared is still going to be I squared minus 2I plus 1. All right, that's what we get. So this works out to be I times the I squared minus I squared gone, the 1 minus 1 gone, and so we get 2I plus 2I, which is 4I. And 4I times I is 4I squared.
Negative 4.
Is negative 4.
So sorry what I was distracted. What question was that again? Number 40?
Number 40. Easy question. The easiest question on the paper.
Expression.
It is true. Easy.
Sir, you're gonna have this link posted again, right?
Yeah, I'm gonna post it. All right. Let me rotate this
Argument.
around. It. All right. Final part now. So the principal value.
Argument.
The principal value of the argument of the complex number 2 minus 2i. Now, there's a thing about complex number where you have to remember the particular quadrant that you're dealing with.
Oh yeah, you have to draw the complex number from the organ diagram, sir.
Yes. So always remember that the argument is the angle it makes with the positive x-axis. And so 2 minus 2i, wait there, 2 minus 2i, x is positive, 2 minus 2i is going to
And
be
I have
up
fourth
here.
quadrant, sir.
Yeah.
So it's
So the
theta
angle it
equal to
makes is this.
tan inverse of y over x.
So it's tan inverse of y over x. So it is 2 minus 2i. And so the angle it makes with the x-axis is tan inverse of
negative 2 upon 2.
Of y over x, which is 2 over 2.
Sir, is it negative 2?
Negative 2 over 2. And tan inverse
Tan
of
inverse of negative 1 is minus pi over 4.
which is just pi over 4. The angle is just y over x. So you can take out this negative, and it's just pi by 4.
You sure, sir?
Yes, positive. Think about it. It's the angle it makes with the positive x-axis. So in the first quadrant, the argument that you get is just theta. In the
And as well as
second
the fourth quadrant,
it is
pi
pi
plus.
plus theta. And why is it
Plus?
pi plus theta? And the third quadrant, it is going to be
Pi
theta.
minus theta.
Pi minus theta or theta minus pi. They're going to give you
Yes,
the
sir.
same thing. And then in the fourth quadrant, it is just theta.
Theta.
Think about it. This is the first quadrant. This angle and this angle are equal. All right? The same thing. And so the angle that we're getting is pi by 4. Pi by 4.
So I thought it would be negative pi over 4 still, no?
Yeah, that's what I got in the calculator.
Yeah, because what you do you put in the calculator tan inverse of negative 2 over 2.
What?
All right? You put tan inverse of negative 2 over 2. But the thing
But
that we
negative
want is,
45 degrees I get in, I said.
yes, I'm saying this is not trigonometry. In trigonometry, right? In trigonometry, you would draw your triangle and you say tan is negative here. And so the angles that you would get in trigonometry would be minus pi by 4 and something else. But the reason for that is in trigonometry, the angle that you measure is from here all the way around here, which would be just be 360 minus all of this. And that's how you get the minus pi by 4. Now, what I want you to do is take away the axis thingy, right? Just look at the angle. So I'm going to take away this and take away this. All right, imagine that I had spin this diagram around. What would be this angle? Think of it as vectors. What is this angle?
45 degrees.
That's just 45 degrees. And that's why it has to be just pi by 4.
All right, sir.
All right, I'm going to show you. Don't worry. I'm going to show you in the notes. So you have to remember that it can be quite tricky. The angle in the fourth quadrant and the first quadrant is exactly the same. The angle in the fourth and the first quadrant is exactly the same. That's a nice little trick question. All right. Now this question, all you're required to do is find
R and
okay, so find R and find theta. R is just going to be
the square root of negative half plus the square root of root 3 over 2.
So let's work that out. Let's do it now. So we have z is equal to minus a half, right? Plus root 3 over 2 plus root 3 over 2i. And so r is just going to be a half square plus root 3 over 2 square. What's that?
The square root of negative 0.5 plus
7/4.
0.866.
And then square root that answer.
Square root of 7/2.
Plus 0.866.
Square root. You get 7/2? Oh, I don't get that.
I got 0.605 in it, sir.
Let's see that. A half square plus √3/2 square. These things don't even need the calculator, but because we're lazy, that's just it. We're lazy. Let's tell the truth. So work it out. What we're getting is a half square is a quarter plus √3 square is 3.
3/4, sir.
And √3 square is that. 2 square is 4. And then we're square rooting.
So that's
1 is the answer.
1. You see, it's lazy. Who lazy, you know? That's so lazy.
John.
That's so lazy. But
Okay.
that's what happens, you know? We have calculator, so we don't need to do anything. So now that we find it, always draw the Argand diagram to look where we're looking at. So it's -1/2, x is -1/2. And so we're in the second quadrant. In the second quadrant, it is pi plus theta. Pi plus theta. All right? And theta, or the arc, is going to be tan inverse of y over x, which is tan inverse of √3/2 divided by 1/2. That's just going to be minus √3. Because we can only, dividing by this is like multiplying by -2. So it's minus √3. What's tan inverse of minus √3?
Tan inverse of minus.
That sounds like minus pi.
Pi over 3.
Minus pi over 3.
Plus pi.
And so we're just going to add that answer to pi. And so the argz
2 pi over 3
is 2 pi by 3.
Yes.
Argument of z is 2 pi by 3.
Pi by 3.
All right. So first thing I want to share you, this is an important piece of information. Oh, I said it already around here. Why am I repeating myself? The argument of z in the second quadrant is pi plus theta. I said that already. Yeah, I don't need to repeat that.
You don't.
So that's it. 2 pi by
tan inverse of negative.
Yes, sir.
Easy question.
√3, sir.
Yeah, you can say that.
Negative pi third. Mr. Ferguson?
Yeah, go again.
The tan inverse of
What
negative
happened?
√3 is negative pi thirds.
Yes, negative pi by 3. And then we'll add that to pi to get the argument of z.
Also, this is
Now,
now in the
this
polar
question,
form.
Yes, it's now in polar form. Very good that you remember the terms. You have the exponential form, the polar form, and the Cartesian form. This is in polar form. All right? That's good that you're really paying attention to the terms, the technical terms. All right? Now, this question asks, in how many ways can the letters P, Q, R, and S be arranged so that the letters R and S are always together? So what's this?
This is permutation, sir.
Permutation. All right, very good. So we have PQ, R, S,
What
and
kind of
T.
permutation this again?
And they want P and Q to be together. So P and Q, they love each other. And so
A restriction, sir.
Yes, so there's a restriction. And so we're going to think of P and Q as one, but they're always together. And so there are 4 factorial ways. Times 2, because P can sit right here and Q here, or Q can sit right here, then P. We just want to know them together. So it's 4 factorial times 2. C. Easy question.
Well, hold on, where you get that, sir?
Oh, I get 4 factorial times 2?
Yes, sir.
So right here,
So can we do the box diagram?
Yeah, here's the box diagram. 1, 2, 3, 4, 5. All right. So think of P and Q as being in one box together. So P and Q are in one box together because them say them have to be together. They are bench and bottom. They're not separate. And so in the
And then we
other
have
three
R,
box
S, and T.
are S
So
and
those will be 3 factorial.
yes,
And
but the
plus the
thing
P
is,
and the Q box will make 1 unit.
okay,
So
4
that's a 1
factorial.
plus 3, which is 4 factorial, right, sir?
4 factorial. So all of them together now, because P and Q can be in this box, or this box.
1 unit,
So it is 4
4
factorial.
factorial.
But then
So
P
again, what?
and Q can be, they can sit this way or they can sit this way.
Okay, so that
So
is why I have
times 2.
multiplied by 2.
Yeah.
Would it be, but in a sense, is it multiplied by 2 factorial?
2 factorial, yes. But 2 factorial is just 2, so we just say 2.
Okay. And the answer is what again? C?
Let's see. Now question D now, 44 rather. It asks us for the number of ways we can arrange the word irregular where the R's are not together. First and foremost, the ways for R to be together is 7 factorial times 3 factorial. We just look at an example like that. So if this is the number of ways they'd be together, then the total number of ways to express or arrange irregular minus the
There are
amount
9
of
letters,
ways.
right?
Repeat? Yes, there are 9 letters. So the total amount of arrangement for irregular is 9 factorial. That's the total. And we can always separate them now because the number of ways for them together is 7 factorial times 3 factorial. So the total number of arrangements minus the arrangements of them being together is going to give us when they're not together. So that's D. That's clear?
Yes.
Yes, sir.
All right. And final question now is a locus question. Always write it in the form Z minus A. That makes it easier.
Yes, sir.
So if you have Z minus 1 minus 2i, I want you to write it as
Z minus in bracket 1
in
plus
bracket
2i.
1 plus 2i. And so now you get the
And the
center.
centers would be 1 and 2.
1, 2. So the center is 1, 2. So you're looking for an answer with the center being 1, 2, and the radius of R, which they said is 3.
So it has a radius of 3 units.
It has a radius of 3 units. 1, 2, and a radius of 3 units. That's C. All right. So that's it for 2010. What do you recommend? What do you think about 2010 paper? Was it bad?
No, it's not bad, sir.
No, it's
Easy,
not.
right?
I have to recap some of the solutions. You know.
Okay. All right. So I also have the solutions written for 2010 and 2009. I wanted to go through 2, but it doesn't seem like we're going to be able to go through 2 in a week. So what I'm going to do is I'm going to send you by email and also post the solutions for 2009 and 2010. And next week we'll go through 2012. All right?
Yes, sir.
Yes, sir.
All right. So have a good night because it's
Sir,
night.
how many classes you did today?
Classes today.
Yes, sir.
What do you mean?
Like in terms of ministry and JC, you know.
Oh, and my others, why you want to know about how many hours I'm teaching a day?
Sir, how many classes do you teach a day, sir?
That's not important right now. What's most important is that we went through 2010, and any issues you have, you can, feel free to contact me. All right, that's the most important issue. We're working towards getting the grade 1s. All right.
Yes, sir.
Right, Ashley? Right, Cheyenne?
Yes, sir.
Going for the 1s, all right? All 1s. I just want after result come out, everybody say, Sir, I got the 1. That's what I want to hear.
That's what I want as well, sir.
I hope so.
All right. It's not even hoping. We're working towards it, all right?
Right, sir.
Yes.
All right. All right. Have a good night.
Same to
Okay,
you.
sir. Good night.